throwing them at you just to start out.
Oh, really?
You start with much more basic ones for this. Okay, the highest order of the derivative is the double prime.
Right.
So that means that the order is 2. Okay, the dependent in this case is y. And it kind of tells you that says y is a function of t. The independent is t. All right, so then anything you see that isn't a y or a t, and it is pretty common for differential equations to be y as a function of t and even x as a function of t instead of y as a function of x. That you'll see that more and more. But the parameter here is just at the epsilon.
Okay. Okay, I'll send you the next page. I'm still trying to get
I got page 2
Oh yeah,
down,
never mind.
or 6. You sent over 6. Page 6, it says for each equation 9 through 17, show that the given function is a
Yeah,
solution.
number 12 is the next one.
Number 12 is the next one. Okay.
Is it the same? Oh no, we're looking at intervals
It's
now.
different. Are there any in the previous grouping? Like I just would ask, like, I feel better if you told me for number like 6. 6 is really an odd one that you might not know right away.
Okay, yeah, let's do that one.
Can I, yeah, let's really quickly talk through that.
Yeah, if you see any funky ones that you think would be a good thing to talk about, then feel free.
Okay. So at first glance, let me read this. This is t y prime of t prime equals alpha e to the t. So you might look at this and say, oh, it's first order because there's a derivative here. But this prime on the outside tells you that you're going to take a derivative of this on the inside. So if you were to take a derivative of the inside, that's product rule. So t y double prime of t plus y prime 1 times y prime of t equals alpha e to the t. And now you can see that it's a second order.
Right, yeah.
From it. And you wouldn't glean that from just, staring at it.
Okay.
So that's all the comment I want to make on that one.
Okay.
The other is that sometimes you see y prime as a function of t instead of just y prime, but it's a small thing there. Okay, number 12, you said?
Yes. And then the rest of the book is unfortunately on back order right now, so I'm having to get these get the problems from
used to be that we could order the books from, I hate saying this, China, because they would just grab copy the book and
right.
But I don't know what the situation is nowadays. If you need help finding, I'd be happy to do some searching for you.
No, I got him. It's just on back order.
Okay, so let me just write this here. It's t squared x double prime plus 3t x prime plus x equals 0. And they're telling you that x equals natural log of t over t. So that goes in for x. But you also need x prime, which means you have to take a derivative of this thing on the right, which is why you learned of all your derivatives over the years. So it's t times 1 over t minus natural log of t times 1 over t squared. And so the first derivative is 1 minus natural log of t over t squared. And that's going to go in for, the second position. Okay. And then we got to find a third derivative or second derivative, x double prime. And yeah, you're supposed to do these by hand. Bottom times the derivative of the top minus the top times 2t over the bottom power 4. So these get, you got to be really fast at these to be able to do anything with them.
Yeah, I got to go back to Cal 2.
T over t to the 4th So you got minus t, but then your t's cancel. So you got 2 natural log t minus 1 over t cubed. And I'm always going to be going to your favorite calculator, derivative calculator, to verify that these are actually correct, especially when you're doing homework. Make sure you got that down. So just confirm these before we move on.
Did you go back up to the top?
Yeah. Yes. Is this far enough, or do you need me to go further up?
No, like at the start.
Okay. Because we can still have to do all this. Like I just want to make sure our derivatives are correct before I go.
Oh, okay. So you just what's the x?
X is natural log of t over t.
Oh, I was looking at 11 on accident. Okay, that makes sense.
So this is right,
Okay.
but I think I messed up the.
Okay, so you just replace. Okay, I see what you're doing. Okay,
we're gonna replace them, but I made a mistake here. Oh yeah, this is negative t. That's why. Okay.
and
So
you
this
did
is
quotient rule
3
to do the
Yes,
rest.
quotient rule for both. Yeah. So
All right.
let me know. So did you get, if you got this for the first derivative, natural log t over t squared? That is correct.
Okay.
And then for this is now correct for the second derivative.
Okay. Cool.
Okay, so now the reason we needed all that is because we're supposed to go back and replace. So it's t squared times x double prime of t. So I have the benefit here of copy and paste. So this goes here plus 3t times x prime. So you grab your x prime. 1 minus natural log of t. Plus x natural log of t over t. And this is supposed to equal 0 when you're all done. This is not a calculus or differential equations exercise, just a calculus exercise.
How do we know it's supposed to equal 0?
That was given. It was given at the beginning of the problem. It tells you, like, make sure that
Right.
when you put this in as derivatives equals 0, it doesn't always equal 0.
Right.
It's called a homogeneous second order differential equation. Does not always work.
Okay.
So some canceling here. You get a t there. That t cancels that t, and then you just as carefully as you can work through this. It's 2 natural log of t over t minus 3 over t plus 3 over t minus 3 natural log t over t plus natural log t over t. And looks like it does work out here. These make 0. And you got 2, 1, that's 3, and then minus 3. So those also equal 0. It's a creative way for your teacher to figure out if you really know your derivatives by asking you these questions.
So now we got to do the intervals next.
That's it for this. Determine the largest interval or intervals on the independent variable in which the solution is defined that satisfies the equation. So that's kind of like going back here. It's like, what does this work for? What's the, because natural log of t isn't defined everywhere, and neither is t. So I believe it's just asking for, like, what is the domain of your solution? And your domain is whatever the domain of this function is.
Oh, okay. It's just asking for the domain of the x.
Yeah, like if you had I guess you don't have the book, but if you had the answer to number 9 would apparently be all real numbers because exponentials are defined everywhere. 11 would be a good one to look at because it probably is everything but 0. So for 12, we're going to say that this is good. For t greater than 0, or you could say 0 to infinity. That's the domain of natural log t over t.
Okay. Okay, that makes sense. Okay. Oh yeah, I need to send you the next ones. My friend just sent me the PDF of the book.
Oh, good.
Send in the next. The next group.
Okay, got that. Just a moment here to get this uploaded. If you want to share the PDF of the book, I'd be happy to keep that in my files here.
Yeah, we'll do that actually. It's a good idea.
All right. I've got it up here. What problem are you wanting us to look at?
Oh, number 2 and number 8 were assigned.
Right. So here's number 2, just confirm equation dy dx equals 4x plus y times y. Here's the function y equals ce to the 2x squared plus 4x. Does that look right to you?
Yes, let me get back to it. Yeah.
Okay, so on the left, on this left side here, you got to take the derivative of the thing on the right here. So you got to remember your derivative rule. Derivative rule is for e is itself 2x squared plus 4x. Derivative of the exponent 4x plus 4. Okay, so all of that, all of your derivative will replace the left-hand side. Okay, and you're just, it's a verify, it's not a solve. You're not like moving things around. So it's c e 2x squared plus 4x times 4x plus 4. On the right, it's 4 times x plus 1 times y. Y is that ce to the 2x squared plus 4x. And you're trying to decide, well, are they the same? And they are the same. On the right here,
Factor out of 4.
Factor out of 4 on the left, or on the right, distribute in. Either
Right.
one is fine. Doesn't really matter.
Oh, okay.
But they should look the same. That's it. There's nothing more to do on that one.
Okay.
You said 8 as well?
Yes.
Differential equations is much harder than this. You're not verifying solutions the whole class. But these are good to
Are you talking
start.
about like the rest of the
Review.
class? This is
Yeah, the rest of the class is way
Okay.
harder. This is just like kind of maybe but you gotta start somewhere. So they on the left here, it's dx dt.
You do the same thing.
Let me just check. Let me read the instructions completely. It says, solve the initial value problems using the given family solution. First show the family solution size indicated. I'll set the exact interval, which, okay. So did we, yeah, okay. So we'll get to that. Basically the same thing. You just have to,
yeah, for number 2,
so
you don't have to do anything else, but number 8,
yeah,
you do.
Now, what I would do here, I guess, is I would maybe put this initial condition in first. Let me see here. State that using given each case. Oh, for all values of the constant. Okay, that's wrong. So first thing is to not do that. You're going to just do your dx dt ce to the t squared times 2t. And so it's another verify, ce to the t squared times 2t. On the right, it's 2t times ce to the t squared.
Okay. What do you do with the x of 0?
Yeah, so then now it says first show that the family solution satisfies the equation for all values of the constant. We did that. So we're done. That's good. And then it says also state the exact interval in which the particular solution of the initial value problem exists. So we want to then find the particular solution. They call it XP for particular.
Okay.
And you're just substituting the the value of 0 in for t. So c equals 1 in this case. And your x particular is e to the t squared. And then they want to know the interval in which this is okay. And I guess I'm just looking at this function here. Its domain is minus infinity to infinity. There's no real issues there
Oh,
that I'm
right.
detecting, but you may want to confirm exactly what
That does make sense. I remember doing, so she
it sounds
briefly went over
reasonable.
that in class.
Yeah, I'm not seeing the one that's got exceptions yet.
Got some more examples in second section. Yeah, it's just these right here.
Is that everything from this page that you wanted us to look at?
For right now, yes.
Okay.
I just kind of want to get the assigned ones out of the way and then come back for more
Sure.
questions.
All right, so I just got a picture sent over here. It's uploading. All right, so 2.1.
Yes,
Okay,
it's the 1 through 4.
all of them. Okay.
Yes.
All right, so number 1 through 4 says determine whether the equation is separable. We should start with one that is. All right, let's start with let's start with yeah, I guess. So what one is not, I don't know why they're asking if they give you one exception. Let's go to 2. Go to 2.
If they're separable, they have to follow the order of like them being in the form dx over dt equals g of t times h of x.
Yeah. So what I would tell you to do is write it as dx dt for number 2. We'll come back to 1, but let's do
Okay.
one that's like kind of right. Plus 2x equals 1. So right now it is currently not separable in its current form, but you can do some things to get it in. So normally you don't add and subtract, but in this case, it does work out. Okay, so you have 1 minus 2x on the right.
Mhm.
Now, you can think of this as being over 1, and then separable, you're literally separating the differentials. So the 1 minus 2x has to go to the left, and the dt has to go to the right. So you're effectively multiplying both sides by 1 minus 2x, and then multiplying. So that clears out the 1 minus 2x. And then I'll show you, let me get that down here. And then you're clearing out the dt by multiplying both sides by dt. Now, I don't know if they actually want you to show this. I haven't done this in so long. I don't remember if this is allowed, if you're actually supposed to show it. But you do, what you're getting to is the separable form, which is the integral dx over 1 minus 2x equals the integral dt. This is the form that they want to see if it's separable.
Okay. Okay, that one confuses me.
Yeah, it's not the best, like looking at 5 would have been better, but
Okay, we can do that. Let's do that one.
okay. Okay, let's look at 5. It's so 5 on the left is really dx dt equals x over t. Okay, so we want all of the x's on the left,
Okay, and all the T, okay,
all the t's on the right, including the dt's. Okay, so you can think of it as I'm going to multiply both sides by dt. All right, and then I'm going to divide both sides by x. So on the left, it becomes dx over x with an integral. Got to write that integral. And on the right, it's dt over t with an integral.
why did the integrals pop up?
So you're not supposed to write a dx without the integral. It's a notation thing.
Oh, okay,
There's a really lengthy explanation out there, I'm sure, but
right.
I hope they're doing this in the classroom.
It's, well, for number 5, it says put in the form x prime of t. Am I just missing it? How is that in the form of x prime of t equals gt times hx?
Okay. Okay, yeah, all right, sorry. So I'm getting to the point where you solve. Let me do what they actually want here. So they want, like you said, they want g of t, h of x. So for this x over t, you want to look at it as 1 over t. That's your g of t.
Okay,
That's your g of t. And then the x, that's the h of x.
oh, okay, okay.
They're just making that like separation of it.
Oh, okay, I see, okay,
And in terms of like, well, how what do you do from there? If you have x prime of t equals g of t h of x, you always divide by the h of x. And that's why that's how you decide. It's like, can you make the right hand side this some function of t times some function of x?
okay. So now going back to the, where 1 through 4 problems.
Yeah, we can go back to it. Let's do 3 next. It's kind of related to the one we just did. Let's put it in that form that it's talking about so that it's clear here. So we really want this to look like the form g of t h of x. Okay, so in terms of what that is on the right here, I can make this 1 over t plus 1 times x plus 1.
Oh, okay.
And so then all of this in parentheses is the g of t, and all of this over here is your h of x.
Oh, okay. It's more simple than I,
So yes, this is separable.
okay.
Let's look at 4. 4 is the same, kind of the same now. So g of t h of x, we can make this sine t times 1 over cosine x. And then sine of t is your g of t.
Right.
1 over cosine x is your h of x. So again, this one.
So for number 1 and 2, could you
One
subtract 2x from both sides?
is the exception here. So 1 is
Oh, it's
not.
not separable.
That's why I was like trying not to do it first, because it was so unclear. So if you subtract the 2x from both sides, which is what you're supposed to do,
Okay,
you get x prime equals e to the minus t minus 2x.
right,
Okay, and I normally tell students, like, normally you don't add or subtract functions because that makes it really hard to make them separable. There's no way to make this
right,
difference into a product. Like it's g of t minus h of x or plus h of x.
right.
you can't make it a product. So this one is a no, big fat no.
I just want to make sure starting off with subtracting the 2x makes sense.
You do,
Now,
and now it works in the second one. And maybe we go back, maybe we look at the second one now in that context of this g of t h of x thing. So when you subtract the 2x, you get 1 minus 2x, and there's nothing in front of it, but you can put a 1 there. You can think of that as 1,
right, yeah,
and that's your g of
that would
t,
be g of t.
that's your h of x.
Okay, that makes sense. I guess, yeah, I just feel like I say this every time. It's just a matter of practicing just to get used to seeing stuff like that and be able to.
Yes, getting get comfortable with this.
So this class is similar to calculus 2,
It's
right?
more closer to calculus 1 and calculus 2, derivatives and integrals,
Okay.
than it is calculus 3.
Okay, well, that's encouraging.
Yeah.
In a way.
Yeah.
Calculus 2 is not fun.
So do you have to do any of 5 through 10 actually solving any of these?
Not right now, but I would love to learn about them.
Okay.
Just to get a head start, because I'm sure they'll be on the next homework.
Okay. Should I just pick like 6, for example, to look at?
Yeah, that worked.
Or do you have other stuff you want us to look at today?
For right now, no.
Okay.
Since we're already looking at this page, we can.
Okay. So like my approach is not to write, I don't write g of t h of x. If you like that, we can do that. But I look at it as I need to get the dt on the right and anything with an x on the left. So I look at it like I'm going to move this x over by multiplying both sides by x and then multiplying both sides by dt. Now, if you don't like that, we can do it this g of t h of x way. What would you like to do?
I like the GT H of X better.
Okay, so the g of t is t and h of x is 1 over x. Okay,
So for would your way be better for solving these problems? Like actually
yeah,
finding
yeah,
solutions?
yeah. But you'll see why here in a moment. But we'll carry it
Okay.
through, and it's not wrong. It's just you get preferences. So you need to divide both sides by 1 over x. Now,
To get all the X's and all the T's on the same or on different
well,
sides.
in full disclosure, I mean, it's x times x prime now equals t. It's not that you even have the dt over here, but it x prime is dx dt. So you can effectively move it over to the right.
Oh, okay, I see what you're saying.
But when you write just a dx or just a dt, you do need the integral symbol.
Okay. Okay, so for solving them, yeah, you can do it your way, and
Sure, I'll try and show both.
it probably seems better.
They're gonna, but see, the thing is, they're gonna use this notation a lot, especially
Right.
when you get to linear first order equations. And I think if you guys use I don't know, there's another substitution that I can't think of, you're gonna use that. So now antiderivative both sides, 1/2 x squared plus c1 now, because there's 2 integrals,
Right.
1/2 t squared plus c2.
Okay. Yep, I remember this.
All right. Now you're supposed to solve for
C1,
the
C2.
yes, but you don't have them. Okay, now you can
Right.
move the c1 over, and you can write 1/2 x squared equals 1/2 t squared c2 minus c1, and then you can say, oh well, c2 minus c1 is really c. And so what a lot of students do after they've seen this a few times is they just write one constant of integration. They just go right to this line right here.
Okay.
To solve for c, you need an initial value, which we don't have.
Right.
Okay, so
So
for
that
me,
would be like
for me,
the X of 0 equal 1.
yeah, if they said like x of
Like that.
0 is something, then you would have it. The problem I have here is I don't know where to tell you to go, because this is correct.
Uh-huh.
You can solve for x squared if you want, but you can't solve for x because x, it's plus or minus when you take the square root. They generally don't give you problems like this that are kind of in this odd form on tests. But I mean,
Uh-huh.
if you multiply everything by 2, so I'll show you that, you get 2c. And you can again say, well, 2c is really c, or you can do some other sort of things here.
So I
When you,
think in class she brought up this point with there being an initial condition, like the x of 0 = 1, it being the actual form of like kind of like y comma or x comma y, like a coordinate,
yes, and
but
we
instead of
need that, and
being
we need that. We don't have that, so we can't really go
right,
much further than this in this
right,
problem. Um,
and it's asking to solve them for
yeah,
that.
I mean, this is solved. So is, all of these lines are actually solved. It's just which one do they want? It's the one that, that's where you want to ask some questions in class.
How is it solved?
Well, your differential equation has the solution x squared equals t squared plus 2c, or 1
Uh-huh.
half x. Like these are solutions. But if that's why
Okay.
there's this thing called a family of curves,
Right. Yeah,
there's actually a bunch of solutions depending on the initial
that's
condition.
true. Yeah. Well, this is just one of them, or like, is this
This is, this is the general form,
general? Right. Yeah. Okay.
and the particular one, the p, comes from knowing the initial
The
condition.
constant or the initial condition. Okay. Right. Yeah.
All right, let's look at 8. Okay, so on the right here, the g of t is 1, and then the h of x is 3x minus 2. Okay, so you're going to divide both sides by the 3x minus 2. Okay, which leaves you with, on the right here, on the left here, x prime 3x minus 2 equals 1. And then you bring that the dt from the x prime, because the x prime is really dx dt 1 over 3x minus 2 here.
Mhm.
You really want to move that dt to the right, and this becomes the integral dx over 3x minus 2 equals the integral dt. So on the left here, the antiderivative is 1/3 natural log absolute value 3x minus 2 equals t plus c.
And then would you rewrite it to solve for x?
Yeah, now I
And
want
then
to make a
do
small point here is if you had the initial condition, this is where you use it. Do it right away. Don't wait to find it.
okay.
So, but yeah, so now we got to solve for x. You multiply everything by
Okay.
3. Exponential both sides. You get 3x minus 2 equals e to the 3t plus c, which is really e to the 3t times e to the c. And then you can say e to the c is really c. So this is ce to the 3t. And you add 2 and divide by 3. So x ends up being ce to the 3t plus 2 all divided by 3.
And that's your general solution.
Yeah, yeah.
Okay. She touched on all these, but she didn't go like super in depth, like in solving them.
Yeah, you're supposed to have the knowledge though to solve all of these, and everything's in play. Like this is really a u substitution integral. You'll
Yeah.
see integration by parts. You'll see trig substitutions. You'll see partial fractions. They don't emphasize them as much because you're learning a new topic, but they're all kind of in play. Maybe completing the
Uh-huh.
square will come into play. Some stuff you might have forgotten. So yeah, these are things to think about, review if you got them.
Okay.
Right. What else are you seeing here that you would like us to look at, or another page, or go back to one of the previous
I'll
pages?
go back.
Like, I know you didn't ask for 18 through 20 on page 6, 18 through 21 on page 6.
Mhm.
Those are similar to the checking problems. You just
Yeah, okay,
take derivatives, plug in X, plug in Y, add, subtract, whatever it's asking for, and
Mhm.
they should all work.
That'd be good practice.
Yeah, these are good practice for, like, hey, I don't remember to take derivatives, or I don't, kind of combine
Yeah.
things.
I'm just trying to look through here. We might could end a little early today if I can't find anything.
By now, you should have more idea of what to ask your teachers, or what
Right.
they are emphasizing for tests and quizzes. Do you know if the tests are in person, online?
Yeah, they're in
What's
person.
in person? What's their style? This
Luckily,
is
I've had her before, so she was my Cal 2 teacher.
oh, good, good. So you already have a feel for what
Yeah.
to expect,
All right.
and that will help you. Might go back and look at your Calc 2 exams if you got them, compared to the homework, see if they're like the same questions,
Right.
um, those kinds of things. Any tests or any quizzes coming up this week, or
Um, not in this class at least.
not in this class? Okay.
Yeah, we aren't doing quizzes in this class. It's on Tuesdays and Thursdays, so I guess it's like a not like a
So like
quote
three
unquote,
mid. Okay.
it's not like a
Sorry.
quote unquote important class. It's not one of those 3 days a week classes.
Yeah. Yeah.
So
Are you exams probably 3 midterms, or midterm and a final or something?
yes, it's three and then one final.
Okay. Weekly homework, or it's all submitted through you're all worked out, any online stuff in this class?
No, it's just all assigned through the book and then we turn it in for via PDF.
Okay.
And yeah, the 3 exams.
It's good to know this stuff from the beginning. When are the
Yeah,
exams? Are they
right.
before spring break? I was looking, helping another student. I mean, he's got an exam right after spring break. That doesn't make any
Oh, that
sense, but
sucks.
that's the way they've decided to do it. Um,
I don't
you know,
think I do. Oh yeah. March is, yeah, I do have an exam.
probably one February, early February, early March, mid-April, with a final.
Um, oh no, never mind. I have an exam right before spring break.
So yeah, tough class, pretty tough class, but most students, most engineers, this is their last math class. Some end up taking
Right.
like an analysis for engineers, which is, it ends up being a lot more of the same stuff that you've already seen, just a review of it.
Yeah.
Depending on your physics, you'll sometimes solve differential equations in some of those classes, or other courses you might see.
Uh-huh.
Um, but you're kind of at the end. I mean, you're kind of, once you're done with
Yeah.
this, you really aren't gonna have much more in the way of math
Yeah.
going forward.
This is my last math class.
All right,
I'm
was there anything
happy about
else?
that.
Is there anything else I can help you with today, or any other questions you
Not
might have for us?
today. I can't find anything that I'm like that's sticking out to me.
Okay. Well, thank you for booking here. Let me just do the usual
I
thing here.
appreciate
Start
your
the
help.